So we have seen that you can define subtypes that extend the parent type. So how do these classes fit together? Because you have some classes which are above other classes. So what is the structure of this Java class hierarchy? So for example, is it possible to extend two classes? So can I define a class C3 which extends both C1 and C2? Right? So it inherits capabilities and instance variables and functions from both C1 and C2. So the problem with having this kind of multiple inheritance is that there might be some contradictory definitions in the two parent classes, two or more parent classes. Suppose for instance, there is a function f here with an identical signature there, right? So C1 defines an f, C2 defines an f, and supposing C3 has no f here. So if C3 does not have an f, then it has to inherit this f from the parent class. But now there are two contradictory possibly definitions of f for it to use. So which one do we use? Right? So this is not easy to resolve. Of course, now this is possibly something you might think is easy to check, but what if I continue and I have, a further hierarchy above this? So it is not in C1 or C2, but it's actually inherited by C1. So this inheritance is actually transitive, right? So if C3, if something extends C3, some C4, it would also get a copy of everything that comes from C1 and C2, right? So in Java, this is not allowed simply because of this possible contradiction, right? Now it's eminently possible there is no contradiction. That is, everything in C1 is different from everything in C2. There is no function in C1 which has the same signature as C2 and vice versa. That means that any function which I call implicitly through inheritance in C3 either uniquely comes from C1 or from C2. But even if this possibility exists, Java does not allow it, right? So Java does not allow multiple inheritance at all. On the other hand, other languages like C++ do allow it if there is no conflict. That is, if C1 and C2 don't have any such clashing signature, then C1 and C2 can be allowed. So this is a design choice. We will see later that there are situations where you would like actually to inherit more than one, because in a sense a class encapsulates sometimes a property. So we discussed earlier about the property of being able to compare two objects. So I would like to give some capability to a class saying that it inherits a comparison function from a class called comparable. But then if it inherits that, it can't inherit anything else because of Java's lack of multiple inheritance. So we will see later how Java allows us to get around this particular bottleneck. But right now, we cannot extend two classes. So that is a syntactic restriction of Java. So since I cannot extend two classes, right? So if I start from here, then maybe I can extend it. Maybe I can extend it more than one way, right? Then these can again be extended and extended more than one way. So you can see that if I start from a class and I look at all the subclasses, they can form a tree. Now, of course, in principle, I could have another class. So I could have here, for example, a class called employee, which has a manager, and maybe it has president and vice president and all sitting even below that. And maybe separately, I have a class which maybe stores dates, right? And there is no connection, obviously, between dates and employees. We also looked at, an order processing example. So supposing I have orders here and items and so on, right? So there is no possible connection between them. So there could be a lot of such things floating around. But in general, wherever I define subclasses, I get a tree. So Java goes a little further than this, and it says actually this whole thing, every class that you write in Java sits inside a single tree. And the way it does this is it creates a root which is implicitly above every class that you write. So you don't have to say, when I say class employee, right, it implicitly extends this built-in class called object. Now this, one might argue, is not a great choice of name because object is a concept and now we are using object as a specific name of a class, but we have to live with this. So Java has chosen this capital O object as the name of this superclass, right? So it is the universal superclass. It is the parent or the ancestor of every class that you ever use in Java. So all your other classes are sitting below this, right? So you might introduce employee here, but it is connected to object. And you don't have to say this, right? You don't have to say employee extends object. It is implicit. So object having an object at that root allows us to define some methods which are available implicitly to every class that we define. So remember that inheritance works that way, right? If I have a class which extends something and I don't define a function in the child class, the function that is there in the parent class will implicitly come down through inheritance. So there are some functions which are useful to have, right? So if you remember, when we wrote Python classes, we had to write these functions like str in order to convert an object into a string. Now that we have this universal object, capital O object class in Java, it has its own function called toString, right, which will convert the instance variables to a string. So any class that you define implicitly has available to it this object copy of toString. You don't have to write it yourself unless you want to change the way you do it, of course, which we will talk about overriding. Similarly, there is an equals method defined in object. So what this equals method does is it compares one object to another object. So typically you will use it in this way, o1 dot equals o2, right? And what this equals method, which is defined in this class object, does is checks whether o1 and o2 actually point to the same object. So this is what you might call pointer equality or reference equality. That is, O1 and O2 are actually, so it is what in Python is called is, right? L1 is L2. Are they both different names of the same memory location? So it turns out that this is actually what is called implicitly when you use equal to for objects. So if X is an object and Y is an object, for example, X may be an employee and Y may be a manager as defined, but if I had written something like employee X is equal to new something, and then I had written manager Y is equal to X, and assuming that this is a legal assignment, that is X was actually a manager type at this point, right? Then if I check if X is equal to Y, the answer will be true, because it will call this and it will say that they both point to the same thing, right? So equal to, when I compare two objects for equality in Java, the default is it goes and refers to the equals that is given in the object class. Right? So that is the translation. Similarly, when I try to print something, if I want to convert it to a string, now in the Python context, print automatically converts. Right? Here the way to convert is to put it in expression with an empty string. Right? If I try to concatenate something to an empty string, then Java will try to type convert the previous part of the thing also to a string to make this plus work. And when it does the type conversion to a string, this implicitly invokes this toString. Right? So I just have to say, if I want to print an object O in some sensible way, I just have to say O plus empty string. So the O plus empty string will implicitly call O dot toString, convert O also into a string, and then concatenate it. Of course, the empty string will contribute nothing to the output. So I will get a representation of O as defined in object as my thing. Right? So it's quite convenient this way that Java has this one super parent class object. Okay, it's a kind of ancestor of every object in the hierarchy, in which these kind of default functions are defined so that they are automatically available to every class you define. You don't have to keep defining these basic functions again and again. So we talked earlier about this notion of genericity, right? So everything can work. So here is a kind of generic find, right? Supposing I want to write a function which will take an array of any type of object and another object of that type and check whether the object I'm looking for is there in the array or not, right? So find takes an array and an object and checks whether O belongs to the object array. So this is just a simple loop, right? I just run from 0 to the length of the array and I keep checking for each of them whether the array at position I in my, the element at position I in my array is O or not. If it is, I return that position. If I run through the entire loop and I don't find it, then for instance, I could return -1 to indicate that there is no valid position where it is there, okay? So this is just a simple thing. But the point is that this now will work for any type of object. So if this happened to be an array of employees, right, and this was also an employee, then comparing one employee with another employee will implicitly check whether, so in this case equality means, remember, object equality, right? They're actually pointing to the same memory location. So it will work whether these are employees or these are dates or these are orders or these are items or anything, right? So it will work for, so long as this array is compatible with that array, it will make sense, and all of them are compatible with object. So remember that when I have something which expects an employee, right, and I feed it a manager, this is like an implicit assignment, right? So just like we said that we can say employee E is equal to new manager. So this says wherever a variable is of a higher type, it can be instantiated to an object of a child type. So in the same way, when I have a parameter of a higher type, I can pass it a parameter which is compatible with it, which is more specific. So since object is the least specific, right? Object is a grandparent or an ancestor of everything. Any type I pass here will work. Okay, and this is now actually separate. So what I said earlier was that ideally you would like this object to be that, but this function cannot enforce that. So I could, for instance, pass a date here and have an employee array over there, but that would not matter because it will just mean that this equality will not work, because there is no way that a variable of type date can point to the same memory location as a variable of type employee, right? But this is a kind of example of the type of function that you can use which exploits this tree-like hierarchy with object, this capital O object class sitting at the root. So now, what if we actually had overridden this equals, right? So supposing inside employee, right, I had written my own equals, which overrides the object equals. Then what will happen is that dynamically at runtime, right, this dynamic dispatch will kick in. So this double equality will call the dot equals, but the dot equals will be that which is most specific to the object at runtime. So then I will actually get an equality comparison as defined, say, in employee, rather than the one which is the pointer equality given in object. So I could, for instance, have an equals function which compares the values of the instance fields and decides that two employees are equal if they have the same name and the same salary. Okay. So let's, for instance, consider a date, right? So date, as we normally have it, has a day, month and year. So you might want to say that I want an equals function for date, which will check whether this day is equal to the input. So I remember that all these things are, so yeah, it's a symmetric thing, right? So D1 equal to D2. But when I say D1 equal to D2, it will be D1 dot equals D2, right? So there will be an object within which equals is called and an object that is passed to it. So the object that is called is D, is this, and the object that is passed to it is D, and I want to check that the instance variables of the object that is called, the this variables, are equal to those which are coming in. So is this dot day equal to D dot day, this dot month should be equal to D dot month, this dot year should be equal to D dot year. If all these things are true, then the answer is true, otherwise it's false. So now I'm no longer demanding that this object and D are pointing to the same location in memory, but rather that they have the same state. Remember, the state of a variable is the current settings of all the instance fields in that object. So the question is, if I want to do this, then is this going to work or not? Right? Now the unfortunate problem is it doesn't work, right? Because I have a signature here which is not the same as the signature there. So in order to override a function, I must actually have the same signature. Right? When we did the earlier example of overriding in the earlier case, we had a signature in both cases for the manager and the employee which said double, bonus, float, something. Right? So this double and float were the same in both. So the manager bonus was shadowing in some sense, or making invisible the employee bonus. Now here, this does not cancel out that, right? And the problem, the reason that this is a problem is because in the loop that we had before, right, I only have objects. So when I use equal to here, I'm actually asking for the equals where the parameter is an object type, because it's going to be obj array I dot equals O, but this is an object, right? So it will only work for the object. So in this particular context, it will work only for the object. So by using the, if I pass a date here, it's not going to use the date function because the date function has a different signature. So it will go back and unfortunately look at the old object type. So how do we get around this, right? So the way to get around this is to actually, first we have to override this function. So inside date, we have to write a boolean equals object. But then if it is an object, I cannot be sure that it's a date, so I cannot start meaningfully talking about the instance variable. So I have to do something like this. I have to take a date in, check that it is a date. If it is a date, then I have to cast it, right? So now I have a different variable which is type date. Of course, I don't have to create a new variable, but it's neater to write it this way. I can put a cast in each of these before the D and do it. And then I can check whether this object is presumably a date, right? Otherwise I will not be invoking this. So this dot day is the same as the converted input D to a date dot day, right? So I have first verified that the input D can be converted to a date, and then I have explicitly cast it to make sure that these things are now legal as far as the compiler goes, because remember, if I don't do that, then the compiler will not allow me to access these instance variables. We saw that earlier when an employee E was pointing to a manager. I could not call the set secretary just because I knew that it was a manager at runtime. I had to cast it as a manager and then only call it. So I have to cast it as a date and then only call it. So you have to have a runtime check to make sure that the type is correct, and if the type succeeds, then you do a cast, right? And of course, if this whole thing doesn't work, that is, this is a date and the input value is not a date, then I just can assume that they are not equal. I mean, I don't have to worry because they can't be the same type of object at all. So there's no question about their instance fields matching or the state matching. So I just throw it out, right? So this now becomes a valid way of overriding the equals in object in the context of that loop that we wrote before. So let's look at this overriding a little bit more carefully. So overriding looks for the closest match in that given context. So supposing we had defined this employee E. So this is like in date, defining an equals, it takes only a date as an argument, right? So we have defined equals in employee, which takes employee as an argument, but we have not defined equals in manager, right? So now I run this code, right? I create two manager objects, M1 and M2, and then I ask whether M1 is equal to M2. So now the question is, what equals is going to be used here, right? Because I have at the top, I have an object class which has this equals with object, right? And somewhere down here I have employee which has an equals with employee, right? And now below this I have manager, right? So this manager equals, remember that if I use manager, right, it can go here and it can go here, because as far as the passing the argument, it's like assigning a value, right? Assigning a variable to a value. So if the value is compatible, that is if it is that type or lower in the hierarchy, then I can assign it. So this call is compatible with both. So the question is, what does overriding guarantee us in this case? Okay, so it turns out that actually we will get this one. So it's like you look up the hierarchy from where you are to find out which are all the functions which are compatible with the call you have just made, right? And you get the nearest one. So you should not confuse this example with the earlier example. The earlier example said that the reason that that date thing did not work is because it was used in a loop, right? When I used that date thing, it did not work this way because I was using it in this loop, right? This loop here where both of them were statically of type object. So in the context of type object, it was not asking for a function whose argument is a date, and that's why the date version didn't work. Whereas here, I'm calling it in the context where both of them are managers. So I know that I want to call manager with an input of type manager. So then it will look for the nearest match going up the tree. Okay. So this will actually use the boolean equals employee and not the boolean equals object which is there in the object class. So to summarize, what we have seen is that Java does not allow multiple inheritance, right? So a subclass can extend only one parent class, and that's because in general, if you have multiple inheritance, you could have contradictions. You could have different functions with the same signature coming from two different sites, and then the compiler doesn't know which one to take in case you have not overridden it. If you're going to inherit, which one do you inherit? Right? So a consequence of this is that any class and subclasses will form a tree, because you can always branch out but you cannot come back. And in particular, what Java does is it makes the entire thing into a single tree by creating this root class called object. So right at the top of the tree there's a predefined class called object, which is implicitly sitting above every class you ever define. So you don't have to explicitly extend your class, it implicitly extends object. So object has these clever built-in functions, equals and toString and all that, which allow you to do equality check and converting to string automatically. But you are of course allowed to override them, provided you override them correctly. If you don't override them, these functions are implicitly inherited by every class that we write. But when we do overriding, we have to be a bit careful to understand how and when this overriding works, because it depends on the signature, right? It depends on the signature of the function that you are calling based on the current context of the call. So if you're calling it in one context, it may call one thing. If you're calling a different context, so that's what we saw. If the argument is an object, it calls something else. If the argument is a manager, it calls something else. So you have to be a little careful to check that the overriding that you intend is actually the one that Java sees. Otherwise, Java might pick up, the worst case, it will always pick up the equals from object, for example, if you're using overriding for equals. But in general, you should be a bit careful about checking the types and the signature when you're overriding.